taking a look at 3.6 here. All right, 3.6 really, all the material we're going to go over in it, you kind of already know. It gives some new terminology to it though. But the basics of it, you're already good with. So, first off, taking a look at your opener. The two angles they have here, the 2x plus 35 and the 3x minus 5, those two angles form a linear pair. Remember, they're a pair of angles that make this line together. Those two angles will have to add to 180 degrees. So that 2x plus 35 plus my 3x minus 5 will have to equal 180. Combining our terms, we get 5x plus 30 equals 180. Bring our 30 over. So we have 5x equals 150. And divide. So we get x to equal 30. Now, if you look at the directions actually ask you to find the value of x. We do not need to plug this in, although you can if you'd like to double check your answer. But your answer is actually 30. Now, the reason I put this opener up there is really it brings up our first idea. And our first idea of today is going to take that linear pair of angles, except it's going to say that as I move this line around and I change the measurements of them, they still have to add to 180 no matter what. But if I stop it so that angle 1 is congruent to angle 2, that means that they are both going to have to be 90 degrees. So angle 1 and angle 2 are both going to be right angles, which means these two lines are going to have to be perpendicular to each other. And that's what theorem 3.8 says. If two lines intersect to form a linear pair of congruent angles, so essentially that example we just looked at, if you made them so angle 1 and 2 were congruent, then those two lines would have to be perpendicular. Now, the next theorem is actually one of the easiest theorems, the most basic theorems, because you already know it. And we actually already talked about it a little bit this year in one of the examples we did in class. If two lines are perpendicular, we mark it by putting the right angle here. However, angle 1 is also going to be 90 degrees. Angle 2 is also going to be 90 degrees. Angle 3 is going to be 90 degrees. So even though we may only mark one angle to be 90 degrees, all four of them actually are. So that's theorem 3.9. If two lines are perpendicular, then they intersect to form four right angles. So if A is perpendicular to B, then angles 1, 2, 3, and 4 are all right angles. All right, then your third theorem of today. If I have a pair of adjacent angles, remember adjacent angles need to share the vertex and they share this side here. So angles 1 and 2 are adjacent angles. If there are two sides of those angles, those non-common sides, if they are perpendicular, then angles 1 and 2 have to add to 90 degrees, which means they are complementary angles. So if two sides of two adjacent acute angles are perpendicular, then the angles that they make are complementary. So basically they're just saying, if BA is perpendicular to BC in your picture, then angle 1 and 2 are complementary, meaning they add to 90 degrees. Taking a look at example 1 then. Example 1 says in the diagram, AB is perpendicular to DC. What can we conclude about angle 1 and angle 2? Angle 1 and angle 2 are both right angles then. Bring us to example 2. Now, example 2 is a proof. You are not going to have any proofs on your test in this chapter. However, I did put one in here just to kind of review because they are going to come back up in chapter 4. In example 2, it says, given that angle 1 is equal to angle 2, prove that 3 and 4 are complementary. So, as in all proofs, we start with a given. Angle 1 and 2 are given. Or angle 1 and 2 are congruent. Now, if angles 1 and 2 are congruent, one of the theorems we talked about mentioned that if these two angles are congruent, then these two lines are going to have to be perpendicular. So my two lines being QV and PS will have to be perpendicular to each other. That theorem was theorem 3.8. Now, if you look at how we just marked that picture then, when we mark those lines to be perpendicular, notice what that says about angles 3 and 4 then. Angles 3 and 4 are going to have to add up to be 90 degrees. We call those complementary angles. And the theorem we went over that exact idea. And that was theorem 3.10. Now, as long as you can explain those in a proof, that's what it matters. You don't need to memorize the numbers. All right, take a look at example 3 then. In example 3, it says, in your diagram, AB is perpendicular to BC. The measure of angle 1 is x plus 15. The measure of angle 2 is 60 degrees. Find the value of x. So these two angles have to add together to equal 90 degrees. Combine your like terms, we get x plus 75 equals 90. And when we subtract our 75 over, we get x to equal 15. All right, so that ends 3.6, part 1 here.